Okay, this is part 2 of the lesson on section 2.7. If you recall, we have already found that f prime of a equals 2a minus 8. So now it remains to find the equation of the tangent line. Now I know we went over this in class, but in case someone didn't get it, because I'm not sure if I showed everyone's papers, and a lot of you got it right, but some of you didn't. So what you need to realize first is that your x value at this particular point, this is where we went the equation of the tangent line. So this was the slope at A. So right now they're basically asking for the slope at 3. So we're going to put it into this equation and get -2. So that's your slope. Use your slope along with your y-intercept and get your equation. So y minus -6 equals the slope times x minus 3, distribute through, and move the plus 6 over as a minus 6, so y equals -2x, in case you missed it in class. Okay, now let's look at some more terms and just ways to look at what's being called the derivative now. So I did mention on the very first page of the first video that when we have a difference quotient like this and we have a limit, then that's going to give us an instantaneous rate of change. And the units can be anything. When we were looking at velocity, this was position, say like feet. This was time, again, maybe like seconds. So the slope of the tangent line to the position function is velocity, because it would be feet per second. So let's take a look in this example of what we want, what we want to answer, and try to always use this wording. So when you see a derivative, or if you see a question asking about an instantaneous rate of change, you want to be able to say, if the function is y equals f of x, you want to always use the words that you see here. Things like, this is a rate of change of y with respect to x at a certain number. Okay, so watch that be done over here. Okay, so let's read this. A manufacturer produces bolts of a fabric with a fixed width. The cost of producing x yards of this fabric is C equals f of x dollars. So that's the cost and x is yards. So we probably want to start by labeling the x and y axis, even if that's all we do. So your x-axis you're going to label with yards, and your y-axis you're going to label with dollars. I'll just be a little bit lazy here. And that's my dollar sign. Oh my gosh. Okay, let's try again. That's still supposed to be a dollar sign. Alright, so A, what is the meaning of the derivative f prime of x, and what are its units? You want to say exactly what this tells you, the rate of change of y with respect to x. So we want to say, and let me type this, the rate, I'm going to actually pause this video for a second because I don't think you're going to see this be typed until I'm all done typing. Okay, so what I was saying, and I was typing it at the same time, was the rate of change of dollars, that's your y, with respect to x, but you could also say per, right? So dollars per yard of this fabric. And that's an answer for A. All right, for B, in practical terms, what does it mean to say that f prime of 1,000 equals 9? Well, again, just think about what variables these represent. So if y was the cost, and again, actually, I guess I should say if f prime equals 9, then 9 is the rate of change of dollars per yard of this fabric, and it says when x is A. So when you have sold 1,000 yards of fabric. Okay, so it's $9 per yard when you have sold 1,000 yards. I'm going to let you write that down yourself. And then which do you think is greater, f prime of 50 or f prime of 500? What about f prime of 5,000? So actually, be the manufacturer. What do you think, when do you think the rate of change of dollars per yard of this fabric is going to be growing faster, or when do you think it's going to be higher? Okay, dollars per yard. It's going to cost you more probably to produce fabric when you're not producing as much. When you produce a whole lot, it's not going to be as high. So this is probably going to be the greatest cost, then this, and then this. And we can talk about this in class on Monday if you want. Okay, so Here, I'm going to have you go ahead and pause, because in about a second, you're going to see the whole solution show up. You want to find g prime of 0 of this function, and then use it to find an equation of the tangent line to the curve at the point 0, 1. So we've already done one of these. I want you to choose an equation. I would suggest, since there's a number, you use the f of x minus f of c over x minus c, the limit as x approaches c, but you can also use the other one. You can use the h equation, either one, and try to do this yourself. So pause it now, because I'm pausing. I'm going to write the whole solution. When I hit record again, the whole solution is going to be here. Okay. Actually, I figured I would give you a little hint. Hopefully you had started right. Okay, now I'm going to finish. Okay, hopefully you got the correct derivative. Then you just need to use, and I'm actually going to write sideways, because I don't know how else to get this done on this page. So y minus y equals the slope times x minus x, and you can see that all you're going to get is y equals 1. And that's the equation. Okay, if you're looking at a table, the process is still going to be the same, but we might have to estimate. So here it says the life expectancy improved dramatically in the 20th century. The table is giving values of E of t, which is the life expectancy at birth in years of a male born in the year t in the United States, and interpret and estimate the values of E prime of 1910 and E prime of 1950. Okay, so we're going to want to estimate the slope of the tangent line for here and for here. And you've done this a bunch of times, even starting with section 2.1. If I were you, I would get the slope of the secant from 1900 to 1910, then from 1910 to 1920, and average those together. That's going to give you the slope of the tangent line, which is going to mean that's your life expectancy per year at that year. Okay, I'm not quite sure where I left off, because, yeah, Tristan and Michael just came in. Oh, guys. Okay, so let's see. Let me just do one of these, and you could do the other one, right? Or at least sort of go through the setup, although you probably already know what you're doing. So to say E prime of 1910, if we want to be organized, we could say we're going to average the slope from 1900 to 1910. So it'd be 51.1 minus 48.3 over 1910 minus 1900, which is whatever it is. Let's see, 3, I'm guessing that's 2.8, 950, yeah, and over 10, and so that's 0.28. If I did check that math, that might be wrong. And no, you can't have bonus if you fix it. And then another slope would be 55.2 minus 51.1 over 1920 minus 1910. And this one I could subtract easier because I don't have to borrow in my head, over 10. So this is 0.41. So then for this, you would average the two of those, 0.28 and 0.41, and I think that's going to be a 0.3, what's that, 9, so 4.5. That's probably what it is, if you add those two and divide by 2. And now the important part right now is how are we going to label this? We would say years per year, if that makes any sense, okay? But this is a life expectancy in years, and it's per year, so it sounds kind of strange. These are not things that you want to cancel out, okay? But it's 0.345 years of change. Like, in other words, at 1910, the life expectancy was going up of about a third of a year. So from 1910 to 1911, you might expect one person on average to live, what would this be if we just say it's around a third, to live about 4 months longer than someone did the previous, than someone's life expectancy from the previous year. Hopefully that makes some sense. And then I will leave it to you guys to try 1950. And no, I'm not going to have that be some kind of a ticket in the door. But you can definitely try that, and we can check it if you want on Monday. Yeah, I guess that was it besides the homework. So we really were done with the lesson. Back on Friday, probably you could have figured out the tables and things yourself, but now you've got a little more discussion under your belt, and we'll do some things with this on Monday, and then we will wait until 2-8 on Tuesday. So if you want to watch the 2-8 lesson also over the weekend, it will be there, but you don't have to watch it. You won't be expected to be responsible for watching it until after Monday night, and we will talk about it, write about it, do all kinds of cool things with it on Tuesday. All right, have a good weekend.